Hello everyone, welcome to this presentation about scanning for security vulnerabilities in embedded distributions. My name is Marta, and I have 20 years of experience in open source development, including 15 years in embedded. I do have a PhD in telecommunications, so I do have security backgrounds, and I have worked in different fields like embedded product development and silicon, and now have moved to distributions. I'm contributing to the Onnero project since April 21 while consulting for OSTC. And now a few words about Onnero because it will make it easier for you to understand how we use scanning for security issues. Onnero is a source-based distribution using Yocto and Open Embedded. We are aiming for IoT space and for consumer devices. It means that the distribution is designed for products with a long-term support LTS version. It also means that we maintain packages for years. One important difference between Onnero and other embedded distributions is that we support multiple operating system kernels at the same time. Operating system kernels like Linux and Zephyr, and various device types, as you can imagine, of different sizes and different hardware features. Onnero is an Eclipse project since late 21. So now, why is scanning important for us and important for you? Onnero is a distribution. It means that we get packages from different sources. In a typical build, we do have around 300 packages. Product builds will be probably quite similar, if not bigger. We are aiming at IoT devices, what means that the attackers can access them easily, and security is a very important subject for us for this reason. And also, an important thing to know is that security issues show up every single day. And even if you are not working on 300 packages per build, you do not want to manually look up for security issues every single day. Now, when we start talking about security issues, there are a few abbreviations that you should know, and let's go through them rapidly. The first one is CVE, Common Vulnerabilities and Exposures. It is a database. It contains unique IDs to issues. For example, we may expect to have soon in the future a CVE 2022 12345. Then we have NVD, National Vulnerability Database, a database that contains the information, the IDs of CVEs, with some additional information like which version of the software is affected, where are the fixes, links to vendor information about the issue and the fixes, and all useful information related to that issue. And then finally, we have CPE, Common Platform Enumeration. Is a standard to describe a product or a software project in a unique way so that we can identify them. And this is the way NVD uses to identify which issue affects which program. Let's have a look now about an example of an issue in the NVD database. At the beginning, you can see the number, and then you do have the description, which writes how the issue behaves, and sometimes a little bit more, information about the version. Then you do have the severity analysis, which tells us how serious it is using the base score and the vector that gives a little more information about that. If you are more interested, we can discuss that later. And then you have references into the tools, solutions, patches. In this case, we do have a chance to have an actual link to the patch and to the commit in the libgcrypt repository containing the patch. It's pretty easy to figure out the patch. And then at the end, we have which version is affected. A few notes from the practice in the security field. CVE isn't the only format that exists. There are some others, but it's the most popular one. So it makes sense to start scanning from this format. But if an issue doesn't have a CVE, doesn't mean it isn't a security issue. Basically, to get a CVE number, someone has to apply for one. Imagine that you are a developer fixing a buffer overflow in your application.